Good morning, students. Welcome to physics class. Today in physics, we are going to see a new topic which is very new for you all, that is integral calculus. What is an integral calculus is if you are integrating any element like this. So these are all the formulas, but we have many formulas which you'll be seeing in max, but let us just know with very few formulas alone. First formula is integration of dx, that can be written as x, because always while doing with integration, this integration and this d gets cancelled, so we'll get with x. Same way, this integration and d gets cancelled, you will get v. So integration of dy, that is equal to y, dt, that is t, du, this is u. Okay. Same way, this is for one element alone, dx. Next, if you are going to consider x into dx, the value is x into x, so it is x square by 2. Next is v square by 2. Next, y square by 2, t square by 2, u into du is u square by 2. Yes, clear with this? Why I am saying with this formula is this is a basic one which we are going to see in the next question. So without knowing this formulas, you will not be able to write with the next derivation. So this derivation, this formulas are very important. Okay. So next is we are going to see the equations of uniformly accelerated motion by calculus method. So we are going to derive the equation of motion. Okay. So for deriving this equation of motion, for this we are considering an object which is moving in a straight line and that has a acceleration a. Let u be the velocity and it takes time to be 0. So at time t is equal to 0, the velocity is u. Then v be the velocity at a time t. Okay. So we are taking u to be the initial velocity and v to be the final velocity, a to be the acceleration. Okay. Yes. So the next is where I told you v is a final velocity, u is the initial velocity. Yes, we are taking as displacement and a to be the acceleration and time taken is t. Yes, clear? So final velocity v, initial velocity u, s is the displacement, a is the acceleration, t is the time taken. Now one more thing is, as I've told you that we are going to take with integration, is it not? So what are the terms we are going to integrate is, first when you take for v, okay, when you take for v, there should be a limit. So limit is the terms which are writing at the bottom and at the top, that are said to be the limits. So what is the limit of v is, it is u to v. Okay. Then the limit of s, that is written as integration of 0 to s. Okay. Then integration of t, so that can be written as integration of 0 to t. Okay. So for s it is 0 to s, t that is 0 to t, and u as well as v. Wherever you get with the term u and wherever you get with the term v, will be writing u to v. Always we have to say from lower limit to upper limit. Okay. So this is how we will be writing the values for the next derivation. Okay. So we will see with the derivation one by one. All the equations are very important. Okay. So first, what are the equation? What is the equation we are going to take is, first take with a is equal to dv by dt. So this is a general equation which you are taking from the acceleration, because the acceleration is equal to what? Velocity by time taken. Okay. So acceleration which is equal to velocity by time taken. Now instead of this v alone, we are writing as dv divided by dt. Okay, this is the first equation we are taking here. A is equal to dv by dt. Then what else will be the other equation which you will be taking is, the second equation which you take is v is equal to displacement by time taken Displacement I am writing here as S, and time taken I am writing here as T, and before this I am writing with the letter D. Okay, so ds by dt. So these two are the formulas which you will be taking in the following one. Okay, now let us take with this formula here. This formula we are taking here. Bring this dt this side. Okay, so this becomes as a into dt is equal to dv. So I am writing as dv is equal to a into dt. Okay, now integrating on both the sides. So integration of dv is equal to integration of this. Okay, in this, when you see, we'll be able to integrate with this v, and we'll be able to integrate with this t, because it is having a term d, but a, there is no term called as d, so this is said to be a constant. So that constant will be keeping as it is, will not do anything with this constant. Okay, so clear. Now as I have told you already, when you are taking with v, the limit is u to v, and when you are taking with t, the limit is 0 to t. Now integration of u to v dv is equal to integration of 0 to t a into dt. Okay, a is a constant, so I am writing as it is. Now we have to integrate this. So what is the integration of dv? That is equal to v, so I am writing it as it is. Now integration of dt, that is equal to t. So this is the first formula which I told you, is it not? Now keep the limits as it is and write the limit as it is inside outside the bracket like this you have to put, and write the limit as it is. Now apply the limits. How to apply the limits is always upper limit minus lower limit. So it is v minus u, which is equal to a as it is, then again upper limit minus lower limit. Okay, now multiply this term inside, so we'll get at minus 0. So minus 0 we are neglecting, this is v minus u. Now bring this term this side, so this becomes as v is equal to u plus at. So this is the first equation. Okay, so what is the first equation is? First equation will get, we got now here is v is equal to u plus at. So this is a very important formula, and also these two formulas we have to know for deriving with the other equations also. Okay, so the first equation which we have got is what? V is equal to u plus at. Okay, then the second equation, for deriving with the second equation, that equation is said to be displacement time relation. Okay, so that is said to be displacement time relation. For deriving with that, as I have told you, we are taking with v is equal to ds by dt. When you want ds alone, bring this term this side, v into dt. Then from equation 1, so what is the equation 1? We have seen already, v is equal to u plus at. So this v I am going to substitute in this place, so we get ds as it is, u plus at into dt. Okay, now the next is we are going to multiply this dt inside. Okay, so when you multiply this dt inside, you get u into dt plus at into dt. So this term as it is. Okay, now taking integration for this fully, so integration of ds, integration of u dt, integration of this. Now here, so this is a term without d. So without d, I told you that that is a constant. So u is constant, writing as it is. Same way here, a is constant, so we are writing as it is. Okay, now apply the limits in this. S, what is the limit for s is 0 to s. Okay, then what is the limit for t is? It is 0 to t. Okay, then what is the limit for t again? It is 0 to t. Yes, now we are going to integrate all this. So if we integrate this, so integration of ds can be written as yes. Same way, integration of dt can be written as t, and t into dt, as I have told you, this formula also, that becomes as t square by 2. Okay, now apply the limits. S minus 0, upper limit minus lower limit, then u as it is, then upper limit minus lower limit, t minus 0, then a as it is, then instead of this t, I'm going to substitute these limits. Okay, so it is t square by 2 minus 0 square by 2. So this can be neglected. Anything, any term which includes 0, that is 0. Then s minus 0, which is s, u into t, 0 we can neglect, so ut, then plus a into t square by 2. Now this a into t square by 2, this half I am taking it outside, so you get s is equal to ut plus half at square. So this is a second equation of motion, which is s is equal to ut plus half at square. The first equation which we got is v is equal to u plus at, is it not? So first equation is v is equal to u plus at. Then second equation is s is equal to ut plus half at square. Let us now see with the third equation. So what is the third equation is? For this, again we are going to take with the first equation, a is equal to, okay, so a is equal to dv by dt. Now in this we are going to multiply and divide by ds. Okay, so if you multiply and divide by ds, in this we get dv divided by dt into ds divided by ds, is it not? So this is the equation which you'll be writing. So dv divided by dt into ds by ds, because I'm going to multiply and divide by ds, so multiply and divide by ds. Now I'm going to bring this dt here and ds this side, so we get dv by ds into ds by dt. Yes, and already we know with what is ds by dt is. ds by dt can be written as what? V. So instead of this ds by dt, I am writing as v. So v into dv divided by ds. Yes. Now bring this ds to other side. So we get a into ds, which is equal to v into dv. Okay. Now, the next step is integrating. So, integrating on both the sides. As you know, yes, the limit is 0 to s, and for v, the limit is u to v. Okay. Now, a as it is, and here, if you integrate this ds, that becomes as s. So, integration of s into limit is 0 to s. And same way, if you integrate here, v into dv, that is v square by 2, the limit is v and u. Okay. Now apply the limits, upper limit minus lower limit. So a into s minus 0. And same way here also, upper limit minus lower limit. So instead of v square, we are writing with upper limit. So v square minus again u square, same divided by 2 as it is. Okay. Now multiply this inside, as minus 0, that becomes a 0. Okay. Then 2, you are going to bring it to other side. So we get 2as is equal to v square minus u square. Now bring this u square to other side. So we get v square is equal to u square plus 2as. So this is the third equation of motion, which is v square is equal to u square plus 2as. Okay, clear? So the first equation which we got is v is equal to u plus at. Then second equation is s is equal to ut plus half at square. Then the third equation here is v square is equal to u square plus 2as. Okay. Then the next equation is, we are going to derive that equation using the first and the second equation. What is the first equation is? V is equal to u plus at. Then the second equation is s is equal to ut plus half at square. First, take with this and bring this u this side. This becomes as at is equal to this. Okay. Then second equation I am writing as it is. Now how we can write this? T square is t square. We are going to write it as t into t அப்படின்னு எழுதலாமா? Okay, because t into t, that becomes as t square. So I am writing here as t into t. Now instead of this at, I am going to substitute this value. So at is equal to what? V minus u. Okay. Now multiply this t inside in this. So we get v into t minus u into t. This half as it is. This should be inside the bracket. Okay, now multiply this half inside. So half Vt, that can be written as Vt by 2 minus Ut by 2. Now this is without the denominator, so we are going to take LCM. So this becomes as 2Ut then plus Vt minus Ut. Now this is 2, this is minus 1. So 2 minus 1 is 1. So we are getting just ut plus vt. Then among these two terms, t is common. So I am taking t outside. So we'll get u plus v divided by 2. So this is the fourth equation. So s is equal to u plus v into t divided by 2. So these are the four main equations of motion. Okay, so this is very important question. This derivation is very easy if you just write for two times. Okay, so what are the equations of motion is? First one is v is equal to u plus at, s is equal to ut plus half at square, then v into v, this can be written as v square. Okay, so a third equation is v square is equal to u square plus 2as. Then the fourth equation is s is equal to half into u plus v into t. Yes, clear? So these are the four equations of motion. Yes, thank you.